going here right now. So while everyone is, can everyone hear? You can't really hear too much up here. Okay, while everyone's coming in, let me get going with the introduction of our next speaker. Our next speaker is from Alcatel-Lucent, one of our pinnacle sponsors. He's from Alcatel-Lucent's wireless division, where he's a senior member of a leadership team and responsible for the development, commercialization, and deployment of the company's small cell portfolio. He has a long history in the wireless and telecommunications industry, having gotten his start at Bell Labs. And so it is my pleasure to introduce to you our next speaker, Mr. Mike Schabel. Mike, please come on up, and we look forward to hearing from you.
Thank you.
There you go.
Perfect. No, I'm good. Okay. I'm good. Thank you. Here's the magic clicker. I figured I would just clap my hands and everything would magically change. So the beauty of time lags or time zones is I had the opportunity to wake up at 3:30 this morning, and so I decided to take a little walk in our casino. And I have to say that the things that I saw were nothing short of sobering. Pun intended. So I'm going to come back to that point in a little bit, because that's going to be a theme that runs through my talk, is the challenge that we all face in this industry, I would argue, is somewhat sobering. Extraordinary challenges, extraordinary opportunity, taken on balance, it's sobering. So let's start with a little bit of history, because history is always a good thing to put us all asleep. I remember 10 years ago, my little phone that I walked around with, where I used to get very excited about taking pictures, and that had something like around 0.3, 0.4 megapixels, and roll the clock today forward about 10 years, and it just doesn't seem like 10 years ago. What does that mean? Well, it turns out the device in the hands of consumers means that we are not just taking really big pictures, but we're sending really great big pictures. And that has an extraordinary impact on the networks that we all need to build. In my case, I guess we need to go provide the equipment so you can go build these networks to be able to transmit this data. I think 10 years' time seems like a reasonable thing that we all can get our heads around, sort of a 10x or 100x evolution of capacity. That's not unusual. But I think the challenge is compounded by the fact that the rate of adoption of what I now call these mobile mini computers is staggering. So if you just go back, again, history is nice to look at because it puts us all asleep. If you go back, let's say, a 10 dozen years, you see the rate of adoption of what we have as the PCs, the rate of adoption of our laptops, and then the rate of adoption of the iPad. And the interesting thing here is the iPad is really what I would call the truly mobile device, because there is no internet jack in it, right? There is no internet jack in it. It fundamentally is designed to be a mobile device. And so what we have now is not only rate of consumption of fancy applications and fancy capabilities inside of these devices, but the rate of adoption, I think, is profound. It's not 100x capacity or 100x improvement in what people want to send in 10 years. It's actually in 2 or 3, it seems, based on the demand curve. Unfettered demand curve. It forces actually to put in some pretty interesting policies to try to regulate how much people send, because otherwise I think we would be in a big world of hurt. You put that all together, and what that means is that whether it's based on devices, applications, or the types of devices that people use, ultimately everybody out there has some sort of projection about what the future will look like. Of course, we're no different. From Bell Labs, we've demonstrated that we think that the industry will grow in capacity. The amount of traffic we have to carry is something like 45 to 85x pictures. Honestly, I can't wait until 2016 or 17 when my mother sends me yet another picture of her dinner, and it's the size of this casino. So with quality and resolution, of course it'll happen. So now we have to actually transmit this. And that brings us then to a bit of a sobering point. We actually have to take care of finances, because it costs money to build these networks. And I don't think, as a consumer, I want to pay to receive that very large data file 45 times more than what I'm paying today. Maybe I'll pay a little more, I doubt it, because there was already great resolution in that food, that picture of the food that she sent. So we have to be pretty careful. In fact, I think this brings us to the real sobering point. We in this industry have to respect the fact that we need to go build not just Erlang networks, which we're very used to, which scale 10 or 20% year on year. We're building an ultra broadband IP wireless network at a rate that is unprecedented in any industry, and we have to do it economically. So it sort of reminds me of my walk down the halls of the casino this morning at 3:30. That's sobering. It's a sobering challenge. So what I'd like to do is spend the balance of my talk sharing a couple of the key things that we have as tools in our toolboxes that are developing, that give us the opportunity to go and actually address this demand curve which is out there. The first what I'll do is actually start out with what we call the truth triangle internally inside of Alcatel-Lucent, because as we heard earlier and will continue to hear, and we should press on as an industry forever, I would say, is we must work on getting available more spectrum to access for delivering traffic over these networks. We took a look at the global picture, not just the US picture, and it's always a little bit challenging when you look at global pictures because you can average out lots of different realities. But the global picture that we are starting to see is that if you take all the available potential spectrum that is actually useful spectrum that we potentially could get access to in this industry, we think that that will actually deliver roughly 2x on average more capacity. And you have to look at the different regional impacts, of course, in the US here as we open up things like 600 meg and others, there are opportunities to go above 2x. But we talked about the demand curve over the next couple of years being 45x. So spectrum is an absolutely essential ingredient and tool that we must leverage in order to get to the demand and to address the demand curve that's coming. And we have to build these networks to be able to support that, because when you add spectrum, you're also adding equipment and you're adding a tremendous amount of product in order and equipment to get into the network in order to address that spectrum. We have to take care of that, but that's a piece of the puzzle. And it's not the only piece of the puzzle. And so we have to look at the other pieces of the puzzle, because we really have to pull on all of those in order to be able to start addressing that demand curve. The other piece is actually then spectral efficiency. And I'm going to spend a little bit of time talking about spectral efficiency. The question is, how efficiently do we actually transmit and use that data, that spectrum that we do have? So that one's a pretty interesting one. I'll talk about that, especially in the context of how you reuse the spectrum that you already have. And it's driving lots of network decisions about the rate of adoption of new technologies like LTE and the speed at which you actually shut down and abandon your previous technologies that you spent a lot of money on building out. Because it's almost like you have no choice. And I'll talk about that in a little bit. And then finally, we'll talk about spatial efficiency. Spatial efficiency is the so-called very exciting small cells space. I'm passionate about that because I run that business at Alcatel-Lucent, so certainly I could spend all day talking about that, but I only included one slide just to make sure we put proper time on these other areas. So I'm going to commit a major faux pas in talking about spectrum, and the faux pas I'm going to do is talk about something one of the big guys is doing. So faux pas in this room, but I chose this because I want to make a very important point. Even if you're the big guy and you have an unbelievable share of spectrum that's out there because you have deep pockets, it's still not enough. Remember, I said it only gets about 2x of capacity of what we were talking about, increasing the capacity. We have to go and be very creative in not only the use of the licensed spectrum that's out there, but we have to get very smart about and creative about using unlicensed spectrum for delivering against the consumer demand that's out there. This one's been what I find to be kind of a tough challenge for the wireless industry to really absorb, is the move into unlicensed and shared spectrum, largely because we always fall back on this issue of quality of service. But I challenge you to consider the fact that, look, when my mother sent me that nice picture of her food last night, I'm not really concerned about quality of service. But when I'm actually doing a video conference, I really care about quality of service. So I think it's an opportunity for us to open our minds to some of the unlicensed spectrum that's available out there that can be integrated into our network solutions. Some of us are doing this, I would say, in ad hoc or disconnected ways, things that look more like a separate network with no relation into associated from maybe billing reduction into our band plans. But I would say that the industry is moving to a point, and the standards are moving to a point where we can actually start to make use of some of the spectrum as part of a complement to the spectrum that we are working on and getting auctioning off and getting in license space. And so HOTSPOT 2.0 plus ANDSF, new technologies actually that are emerging, allow us to then integrate things like seamless mobility between the Wi-Fi network and the cellular network in a very straightforward way. It may not have the same excellent quality of service I think we've all come to expect as what is available on the licensed spectrum. But I think it's something really that needs to be considered and integrated into our long-term plans because frankly it's available. The technology is actually pretty easy to get out there in a reasonable way, and you can integrate it post facto inside of your network at some later stage when you're ready. So don't dismiss this. Think of this and embrace this as an opportunity to really compete against some of the licensed spectrum type challenges that exist. Now let's talk a little bit about LTE, and I'll spend a few more slides there, or a few more slides on this. Our view is that LTE provides us yet another tool in the toolbox, another 50% or so improvement on the overall capacity. Our friend Shannon actually said that you can't get more. So despite what we would like to do and get up to higher spectral coding efficiencies, I think everybody's running around trying to dream up what 5G will be in the future. That's great too. But Shannon actually has dictated how much we can do with respect to getting, sending bytes through this spectrum. The challenge, though, is that given the very limited amount of spectrum that we have that's out there, if you occupy that traffic or spectrum with 2G and 3G based technologies, which are not as spectrally efficient, you're effectively paying more to send those bytes in that network. And what we need to do is, and I'm starting to see this globally, is a very aggressive path by which you get onto LTE because it's more spectrally efficient, which means it's more cost effective to send those bytes, is the way to think about it, and get out of the previous technologies, 2Gs and 3Gs. And that's actually a pretty uncomfortable discussion because in fact we've been investing and continue to invest, and everybody's continuing to invest on the growth of a lot of those 3G networks that are occupying the spectrum that's out there. So it's a very challenging, again, sobering, I think is perhaps the right word to describe it, because we have to really relook at some of the business models that are out there to make sure that we can get there. I think the one comment that I'll make is that as we move forward 2, 3, 4 years in advance, I personally question whether or not folks who are reluctant to make that jump, what their value proposition will be in 2, 3, 4 years in advance in relation to what the competitive environment will look like. And that's a very challenging thing because it almost forces the hand. It forces the hand that you almost have to move now, or you are having some pretty big impacts on what the long-term future will be of holding on to those older technologies. Certainly there's value of those technologies with respect to things like machine-to-machine and some of the applications that they can deliver. But I think because of spectral efficiency and anticipating what the future looks like, it almost tells you that we need to get ahead of this curve. So think through the timing over which you can make that decision. And if you wait to make that decision, it could pose bigger and bigger challenges in the future. The good news is that it's not only more spectrally efficient, but you can have more fun with it. You can get some nice data rates through it and send more applications through it. And so, not that I'm not trying to endorse iPhone over any other technology. This was just a nice marketing picture. But I think the point being is that we're actually starting to see substantial improvements in what people can do in enabling that ultra broadband experience. It's not enough, actually. I find myself still getting frustrated that my LTE network is not fast enough, and I would say it's pretty darn fast. In fact, actually, it's rivaling what my DSL network is at home, but because of the things that I'm starting to do with my device, it's still not fast enough. But it's a good start. And the good news is, as well, not just in the US, but globally, what we're seeing is that people are paying more money for an ultra broadband experience versus what they would pay for the Erlang-based data plan, or Erlang-based plan. So consumers globally, in the US, in Japan, in South Korea, and China will be the next major country to follow when it comes to huge populations of people moving over to an LTE-based environment, and we'll see what happens in that regulated environment, what happens to the data plans. But we expect that actually, again, we'll see that there is a modest improvement in ARPU. It does not solve and close the equation with respect to the cash flow that needs to be analyzed or needs to be addressed. And there's a lot of other tools that we need to implement to drive that. But it's a good start. So at least we're not necessarily going to reduce ARPU. We do think, though, that it's time actually to just go build those LTE networks. And of course, the skeptic actually would look at my statement and say, Mike, that's just to your advantage because you're a vendor, an equipment vendor, and you just want to sell LTE kit. Okay, fair. Maybe that's right. I think, so I won't deny that, but I think there's actually a meaningful strategy behind that, which is we have to think very carefully about long-term continued investments in older technologies that I think we've built out, they're available, so the temptation is to use them for the long term. In fact, the temptation is to try to sneak LTE on exactly that same equipment. I think when we come back to that 45 to 80x, what you start to recognize is that the scalability of the existing 2G, 3G networks is limited and modest in relation to how far we can take them. And so what you end up with is a bit of a stranded asset that requires more investment. So if you start to project out what the financials look like on a P&L of the carrying cost of that legacy network and continued improvement of that legacy network, the challenge can be really quite interesting in carrying that forward. It then sort of says, and again, one strategy is and we're starting to see this a lot in interesting places, for example, in Europe, for example, in South America, where it's a stop, cease investment, flip over to, and we're starting to see this, of course, we already saw this in the US, cease investment in the previous technologies, put your eggs into the LTE basket, and then as quickly as possible, get over to something like VOLTE to remove those services off of the 2G, 3G, do a full migration onto LTE, which would be the spectrally efficient solution, and then refarm that spectrum. Make it re-available so that way you can continue to grow. It's a difficult subject, and it's a difficult transition, and it tends to be a bespoke transition for every they have. The good news is the technology is coming available to be able to do that. And in fact, actually, the technology can, despite Shannon's limitations, we do have a lot of things in the long-term evolution pipeline to be able to carry us forward with continued growth on those networks, specifically through software updates, carrier aggregation being a very nice example, things like EICIC and coordinated multi-point to be able to use these solutions, and I'm saying way too many technical terms for something like this. No? Good. In order to get us to the point where we can leverage that technology. So I think we have the runway with LTE. Think about what the long-term future looks like in combination of spectral assets and what we can do with LTE. The last thing I'll do is say that we need to make these networks in order to actually get to the 45 to 85x curve. We had a couple of X actually available through the spectrum, 50% or so, maybe 100% improvement by moving to LTE and LTE advanced. And Shannon will dictate how much more we can get out of 5G whenever that's defined. But the other piece of that, the third part of that triangle, is moving to more spatially efficient nodes. And what that simply says is that if you want to provide more capacity, you need more nodes. If you add more nodes, then we end up with this massive RF interference problem, which says that effectively, your effective RF pattern actually has to shrink. When it starts shrinking, there's no use putting 40 watts into something that actually only has a transmission distance of 100 meters. So why don't we shrink the power? And all of a sudden, you start to realize these things look like small cells. So the logic says that as we go and try to build scalable networks that we can build for the long term, and as we make these investments, that these aren't things that we have to rip out every 2 years because they don't scale. The good news is I think we have the technologies becoming available that allow us to start scaling these networks as your consumer demand grows. And small cells are a piece. The next piece that actually will allow us to get and put all together 10x or so out of small cells, depending on how much you penetrate out there. 2x or roughly that out of spectrum, and roughly 50% out of the move to LTE. I think gets us on the walk. Gets us on the walk over to addressing the future scalability concerns that we think will be emerging from this migration from an Erlang principled network to an ultra-broadband IP-based scalable network. So, bringing it back to the triangle, I think we have the starting pieces. We certainly don't have all the answers, but I think the good news is that we're ready and prepared, I think, as an industry to start taking that walk. So with that, I thank you for your time.
Very good. Thank you. Thank you, Mike. We really appreciate having you here. I appreciate your insight. Reminds me of one of our board members, Mr. Hugh Mina, reminded me, he said, never get behind on your G's. Well, I think he just demonstrated that as a good line of advice. Let me see. I want to make sure I thank Alcatel-Lucent also for the Pinnacle sponsor. And now we would like to